Hi, everyone. I'm here to talk about PivotalR, which is a new R library that provides an R interface to the Pivotal platform. I, from the predictive analytics team at Pivotal, was the lead developer on this project, and my name is Wu. I'm part of the data science team at Pivotal. I want to start things off by describing a traditional analytics workflow using R. Under this scenario, data are loaded from a source. They're modeled in an outer database environment in R. And once the data scientist is happy with the model, predictions or scores, let's say, are pushed back to the database. Now, such an approach works well when the amount of data can be loaded into the memory of R, and also when the transfer of large amounts of data is inexpensive or fast. But here we're exploring situations involving large data sets where these assumptions are violated. Now, if you're already familiar with SQL and are an expert SQL user, then maybe this isn't as relevant to you as it would be for other folks who are much more, let's say, comfortable in R, but sort of less versed in SQL. For these folks, what we've come to notice is that there are many tools like MADlib out there, which is an open source library for highly scalable in-database analytics, which are actually the interface for that kind of tool is in SQL, but folks who are very comfortable with R and not so comfortable with SQL have been sort of not able to leverage tools like MADlib for the big data analytics projects. So MADlib provides a bunch of sort of canned SQL functions that run in database machine learning algorithms. But more basically, even more fundamentally, in addition to statistical model estimation, in order to do data science, you need to be able to really run traditional SQL queries, including joins for the data processing step. And these sorts of things also benefit from the performance and scalability of a distributed and parallel computing platform like Pivotal. Right? You don't want to be doing these sorts of joins and merges in an out-of-database environment, let's say with R running on your laptop. So PivotalR sort of aims to address this gap, right? So PivotalR, the goal of PivotalR is to harness the familiarity of R's interface and the performance and scalability benefits of in-database analytics. And even if you're someone who is very familiar with SQL, and and there are obviously many folks out there who are well-versed in both SQL and R, sometimes you might just want to keep all your modeling processes in R and write all your modeling code in R, in which case PivotalR would also be something that would be beneficial for that kind of workflow. I myself have been an R user since the 1.x days, and I feel like it's a very natural way to process and analyze data. And so this sort of came out of an idea that some folks in the data science team at Pivotal had last year as we were actually prepping for a conference presentation around R integration with Greenplum and Pivotal. And we thought that, hey, wouldn't it be nice if someone who's completely well-versed in R but knows very little SQL, wouldn't it be nice if this person would be able to leverage the power of something like MADlib? And that's sort of where we kick things off with this project, or how we kick things off with this project. Now, for those of you who are familiar with sort of the Pivotal ecosystem and the tools that are available on Pivotal, you might be aware that we have full support for PLR, which is the procedural language extension for R that is parallelized in the database. And yes, while PLR does provide a layer of integration with R, I think PivotalR is different for a couple of reasons. Now, PLR is great. It's wonderful. It allows you to leverage all the libraries on CRAN, but it mostly focuses on explicitly parallel jobs, right? And sort of another thing to keep in mind with PLR is that it scales to each mapper. So if you think of a PLR job as a big MapReduce job where you have a bunch of mappers running on each segment of Greenplum, the amount of memory required by each mapper scales to the amount of memory on each segment. And also, this is primarily a SQL and R interface for the end user. Now, given what we have available with PLR, wouldn't it also be nice to have an interface and a tool that is, implicitly parallelized, right? Scales to the database, not just each mapper, and primarily an R interface for end users who are less familiar with SQL. So this is where PivotalR enters the picture. The challenge is that we want to harness the familiarity of R's interface, while at the same time getting all the performance and scalability benefits of in-database analytics. Well, there's actually a simple solution. All you really have to do is translate R code into SQL and push that R code into the database where it can execute completely and natively inside of the database. So I'll walk you through some details here. So let me start off by explaining what this diagram is. So this is a diagram that attempts to explain the underlying design of PivotalR. So on the left side here, you can imagine this being maybe even your laptop machine that has R running on it, and you have no data sitting here. On the right-hand side here, you have, say, a Pivotal Greenplum database with MADlib installed, and all your data is here. Right? So you establish a connection between sort of this client machine and the database through, let's say, Joe Conway's R PostgreSQL package. So let's see how this works here. So what happens is, using the PivotalR library in R, you bring that up on your client machine, and the end user writes R syntax, writes code in the R language. And what PivotalR does is that it translates that R code into SQL. And that string of SQL is then pushed across this R PostgreSQL pipe and sent to the database. Now, once that SQL is in the database, it gets executed in the database, and all that heavy lifting is done, again, purely inside of the database. After, let's say, the regression model is run, you get your computation results back. And this could be things like regression coefficients, t-statistics, p-values, what have you. And those summary statistics are then sent back through the R PostgreSQL pipe back to the client machine on the laptop. So this is really kind of cool because the end user is writing in R. To the end user, everything is R code. But what's happening in the back end is that all the heavy lifting is happening inside of the database. And there's very minimal data movement between the database and the client machine. So with this framework in mind, PivotalR provides an R interface to traditional database operations. And what I mean by that are, your select statements, your joins, and those sorts of things are actually now expressed in familiar R syntax. For those of you who are very familiar with R, you'll know that there is a function called merge. Well, what merge really is just sort of the R equivalent of a SQL join. And so in the back end, when a user supplies a merge command using the PivotalR package, that merge command is then translated into a SQL join statement, which is then executed inside of the database. In addition, one of the nice things about R is its sort of rich ability to manipulate data frames and matrices. So I'll show you more of this later when we do the demo, but you're actually able to call specific columns using R's ability to manipulate data frames. And PivotalR is able to mimic that very closely, and then again translate those sort of translate some of those R syntax commands into SQL, which is then executed inside of the database. Now, we've just talked about traditional database operations, but what's really exciting now is that PivotalR provides an R interface to MADlib. And this is sort of really the main reason why we even started thinking about devoting time and resources to a project like PivotalR. So MADlib, and excuse me, if you're not familiar with MADlib, I do recommend that you check out madlib.net. It provides not only downloadable source code, but also documentation on all the algorithms that are available on in the library. But PivotalR provides essentially R front ends to MADlib's in-database machine learning routines. So the syntax is also analogous and closely mimics native R functions, right? So there is a linear regression module in MADlib, and there's also an LM command in R, right? So what we've done with the PivotalR package is create a new function called MADlib.lm, which mimics the syntax of the native LM function. And again, I'll show you a little bit about what that what that looks like later when we do the demo. And this is great because again, the data never leaves the database. It's all it all stays there, and all the heavy lifting, including model estimation and computation, are also done inside the database. Now, at the time of this recording, we are at our first release of PivotalR, and current functionality that we have right now are the following. So we have MADlib wrappers for linear regression, logistic regression, and table summaries. But not only that, we have a rich set of support for R syntax. So all the things that are listed here are the kinds of things that you are able to express in PivotalR within the R window, which will then get basically translated to SQL automatically. Right? And in addition, what's really exciting is sort of automated categorical variable support. So one of the nice things about R that's I think oftentimes underappreciated is its factor class. Right? You can specify categorical variables as factors, and many times, let's say in a regression context again, this provides a shortcut to prevent, let's say, manual dummy coding of categorical variables. And currently, even in our first release of PivotalR, we have support for as factor on PivotalR objects. Now, I also just wanted to spend a little bit of time explaining the class hierarchies that our lead developer for PivotalR, has put together for this package. And at the core of PivotalR is this sort of new R object called the DB data frame. And there are essentially three kinds of subclasses for the DB data frame. They are the DB table, the DB view, and the DBR query. And the DB table is essentially an R object that points to a table that lives inside the database. The DB view is, analogously an R object that points to a database view that lives in the database. And let's say you do some manipulations in R after you've assigned a specific SQL table to a DB table object in R. What then happens is that inside of R, this turns into DBR query object. And what a DBR query object is essentially it's a select statement in SQL under the hood. And what you can do with this select statement is actually materialize it, right, by issuing this as.db.dataframe command, which will then take this db.r query object and essentially cast it to a db.table object in R. While it does that, it also actually writes a real database table inside of the database. Now, this diagram is meant to sort of provide a conceptual overview of the class hierarchies that are available in PivotalR. But really, things will just become more clear once we go through the demo, and we'll do that in just a bit. Just wanted to take a minute here to recognize folks who have been crucial to the development of this R library. And the lead developer is Hai, who is part of the predictive analytics team at Pivotal. And I'm Wu, I'm part of the data science team. Now, there are also resources available to you around PivotalR. You can get a download of PivotalR from GitHub or Qian. Also, there's a practitioner's guide to Pivotal and R interoperability on GitHub. I can show you the link of that just in a second. And if you have any questions or feedback, please send them to user@madlib.net. Okay, so there's enough of the conceptual stuff. Let's now do a real demo of PivotalR and show you some examples of how it runs in action. Now, just before we go into the demo, I just wanted to walk you through some of the web resources available to you about PivotalR. This is the landing page for the GitHub project on PivotalR. This is the URL up here. Also, I mentioned that there is a practitioner's guide to all things that are from database in R, and this is the current landing page for that resource. So on this page, not only cover PivotalR, but spend a lot of time actually and space to describing how to leverage PLR on Pivotal database. Section on PivotalR is here, and I will actually provide a recording of. Actually, yeah, this is actually probably where you will have found this recording that you're watching right now. In addition, you'll find the demo script that I will use for the demo portion of this presentation. Now, this page is a work in progress, and more content will be added to this page in the future. I just wanted to let you know that this is out there and available to you folks. Okay, let's start now. Let's start the demo finally. The first thing that you want to do is, well, you want to install PivotalR on your laptop, basically, right? So what you want to do is, first of all, go to that PivotalR landing page on GitHub, which is over here. Then what you want to do is download a zip file of the package. Now, probably by the time you are kind of seeing this recording, we will also have uploaded PivotalR to Qian, so you can also find the library on that repository as well. Now, keep in mind these are installation instructions for those of you on Macs, but obviously if you're on Windows or something, it's going to be pretty analogous. So once that zip file is downloaded, let's just click on it, right, and unzip it and create a folder. Now, once it's downloaded, you want to go to your Finder window, which is over here, and unzip that, and it's going to create a directory for you here. And basically, just kind of remember where this directory is, right? The next thing we're going to do is we're going to then open up R. And then we're going to install the package. What we want to do is pull down and say, I want to install from the local package directory, another location, and let's do that before the directory that was just created. Open. There you go. There you go. Now you can see that it's done installing PivotalR. And like I said, an alternative way to install this package is through Qian, and you can do it much more easily that way. Now, once the library has been installed, what you want to do is load the PivotalR library and connect to the database. Okay, so let's start by doing library, PivotalR. There you go, so that loaded up successfully. And actually, the first thing that you want to do is issue a DB connect command, because, right, I mean, the first thing that you want to do is be able to reference tables that exist in a certain database. So here's how you do that. I'm going to paste this command in there. It's a function called DB connect, and what you do with this function is you supply the database name, the database user, and the database password for that user, and also obviously the host, if it's a remote host. So let's go ahead and press enter. And as it's doing that, because remember, if you remember that diagram, the pipe between R running on my laptop and Greenplum database running on VCA is provided by our PostgreSQL, which actually runs DBI in the backend. So that's why a required package, namely DBI, is getting loaded up as we're doing that. And now now that we've established a connection to the database, let's see sort of what this connection looks like, right? This DB list command gives you a way to just review your connection, make sure that you're in the right place. Now you'll notice that after we issue the db.connect command, a message says that we created a connection to database with ID 1. This just basically means that PivotalR supports multiple database connections in a single R session. So if I, somewhere in my workflow, if I want to connect to a different database, then I would again issue another db connect command, and then that connection ID would be, ID equals to 2. But in most cases, I think for the majority of workflows, you'll probably end up connecting to a single database. Okay, so now that we've connected to this database, let's, the first thing that you want to do is just figure out what's in this thing, right? What's in this database, and the way to do that is through the db objects function. Let's issue that command, and basically it pretty much prints out all the database objects that exist inside of that PivotalR _ demo DB database. We're going to have a lot of stuff here. These are all tables. Another kind of nice thing is that you're also able to drop database objects directly from R with PivotalR, and that's given through the delete command. So let's say, for instance, that you want to delete a certain table. Let's delete the one called census 2mil1. You can issue this. And 2mil1. You can issue this command. This will then delete that table. With the warning there, but actually I think we can ignore that warning for now, because then if you reprint all the database objects, you'll notice that that census 2mil1 table is now no longer exists in the database. Yeah, sometimes you get just a warning message like that. It's not an error message when you're deleting tables from the PivotalR library. Now, let's suppose that you are familiar with this database, and in particular, you are interested in analyzing the data that exists in the table called census1 _ part1. Right? So what you want to do is create a db.dataframe R object and have it point to this table in the database. How do you do that? Well, call this database object b1, and it will be db.dataframe census1 part1. All right, so what this is doing is basically D1 is now a pointer that points to the table called census1 _ part1 in the database. Let's take a look at what the class of D1 is. So it's a DB table object in R. And let's also take a look at the names of D1. Note that This is the same syntax as you would supply on a regular R data frame, but it's now getting applied to DB data frames. And this tells you the variable names, the column headers of the table called census1 underscore part1 that lives in the database. Now, because D1 is a direct pointer to a database table that lives inside the database, the R object is a db.table. Most of the R objects that you'll be dealing with under PivotalR is either going to be a db.table object or a db.r query object. We do some manipulations on D1, it then immediately becomes transformed to a db.r query object. And you can pretty much pass from one class to the other. So you can make a DB table, a db.r query object, and vice versa. And some of that will become more clear as we go along with this demo. In addition to getting the class of D1 and the names of D1, you can also get the dimensions of D1. And this is has about 15 columns, and it's a 20 million. No, excuse me, 2 million row data set. Oh, let's see, that's 20 million. That's that 20 million row data set. So what you can do is you can also there's a function called preview, which also lets you, as its name suggests, preview the data. So let's say I'm going to preview D1 and just fetch me 10 rows from that table. And in the backend, this basically just issues a select statement with the limit 10. And this is sort of what the data looks like. Another kind of cool thing that you can do is you can do a preview. Let's say you don't really care about all the columns in this table. You can just say, hey, just give me a preview of the first 4 columns, and give me just the first, give me just 10 rows from that table. So again, rich support of R's syntax and how it manipulates data frames. And so yeah, it does exactly that. It gets the first 4 rows and just fetches 10 rows from that table. Now, another nice thing that PivotalR currently supports is providing descriptive statistic summaries of a table. And this is, you can think of this as a richer version of R's summary function. Let's try that one more time. Let me try that one more time. So sorry, I just brought up the help page for a DB data frame, but actually go to the summary page. And not only does it provide mean values and quartiles, it also provides things like most frequent values and how frequently they occur. Now, keep in mind, this is a 20 million row table with over a dozen columns. If we were to do this natively, completely, it would have taken probably a very long time for this to execute. But what I want to do is, let's kick this off. So let's do a summary. Summary of D1. Just kick that off. And while that's running, I'll take a look at that help file, so we can walk you through what's in here, right? So, as I mentioned, it's a pretty rich summary function that has options, asking you basically, do you want it to return things like quartiles? Do you want it to return things like the most frequent values, etc. And how many of the most frequent values you want it to return? And also distinct values and quartiles. So lots of things here, and I definitely encourage you to read through this documentation if you get a moment. So what's happening here in the back end is, it might take a minute or two, but it's basically computing each of those summary statistics inside of the database on that 20 million row table. And again, none of the processing is actually happening inside of R. It's all happening inside of the Pivotal database. So what you can actually also do with the summary function is, if you don't want it to compute the summary for, let's say, all the columns in a table, you can have it focus on a selection of the columns using, this kind of matrix subset syntax that we just went through earlier. Okay, so function just finished running, and what it returns is basically a column by column summary of each of the fields in that table. So like I said, let's take a look at the column called earns. It gives you its data type, the number of rows it has, distinct values, missing values, blank values, percentage of the values that are missing, percentage of the values that are blank, and then of course your descriptive statistics like the mean and the variance, and then the max, quartiles, and also most frequent values. So this is the first line is the most frequent value, and then the frequency of the values sort of in that same order. And again, what this is doing in the back end is it's calling, so MADlib has a function called summary, and it's calling that function in the back end and executing that SQL and doing those computations inside of the database. And it's really just returning the printed output in R. Okay, so let's now that we're happy with sort of looking at the summary statistics, let's suppose that we now want to do some data transformations. Right? So just to recap, let's take a look at what the class of D1 is. It's a db.table object. Now here's what I mean when I was saying before that probably most of the R objects that you're going to encounter in PivotalR are either db.table objects or db.R query objects. Well, here's sort of how a db.table object could morph itself into a db.R query object. Okay, so let's take a look at the names of D1 again. And we have a column called earned and a column called hours. Well, we could easily, make the case that you want to compute wage, which is just the quotient of earns over hours. Right? So do that, and let's actually add that as a column in this table. Right? So we're going to call this new column wage, and it's going to be computed as earns divided by hours. Okay. So yeah, now let's do names of D1, and you'll notice that there's a new column now called wage, which is earned over hours. And what we could also do is now let's take a look at the class of D1. Class of D1 is now a db.R query object, and no longer a db.table object. And this is kind of more for the developers and sort of the advanced users, but there's also a function called content in PivotalR. You can do that. It actually gives you the string of SQL that object represents, that db.R query object represents. Okay. So now, what we can do is we can do a preview of D1. Let's get 10 rows from it. And, I wasn't lying to you. I mean, it really is earns divided by hours. And that's represented by this column that's now called wage. Okay. So now let's say, now that we're kind of happy with this table, keep in mind that right now it's just a db.R query object. Let's actually now materialize sort of this table into a real database table inside Greenplum. Right? And the way to do that is through the asDB data frame function. And it basically it could take two arguments, where your first argument is, let's say, the R query object that you created inside of R via PivotalR. And second argument is just a string indicating what you want to call the table inside of the database. So we call this one, the original table is called census underscore part one. Let's call this one census underscore part one final. Now I reassign D1 as a db.dataframe that now directly points to a real database table that lives in Greenthumb. So now if I do class of D1, you can expect it to now be reverted back to the db.table class. Just check that. And there we go. Now we're back to D1 being sort of a pure pointer to a real database table that exists in Greenthumb. Okay, now that we've done some data manipulations, let's get to the fun stuff. Let's actually start building some models, right? And like I said, PivotalR, probably the coolest thing about PivotalR is that it lets you run MADlib functions directly from R using familiar to R syntax, right? So one of these functions that are available to you is called MADlib.lm. Take a look at the help file for that. So here it is. This is the help page for MADlib.lm, and as you can see, a lot of it, or probably will become more clear when we actually execute the function. But the syntax is pretty much similar or almost identical to the syntax of R's native lm command. So let's get started. Let's build a model using D1, and remind yourselves what columns we have in D1 again. And why don't we build a regression model where let's call the model object M1. Why don't we regress and have wage as our response variable. And professional here is an indicator describing whether or not a particular person has a professional degree. And also rooms is kind of an integer variable that says how many rooms this person has in his or her home. This is really just a model for demonstrative purposes. I know it's probably a pretty stupid model, but let's just go with it and run it. So what this is doing is, recall that D1 is a 20 million row table that sits in Greenthumb, and what I'm telling it to do, pure R syntax is, well, that already finished, is give me a regression where wage is the response variable and professional and rooms are the explanatory variables. And so just like you do in regular R, you can get a summary of M1, which gives you all of the summary statistics from this model. In addition to linear regression, at the time of this recording, we also support MADlib logistic regression module from PivotalR. The aim is that we eventually want to support all of the algorithms that are available in MADlib on PivotalR, and that will happen very soon. But yeah, let's say now that you wanted to build a logistic regression model, and that's actually achieved through the madlib.glm function. We can call up that help file. Again, it's pretty similar. The syntax mimics that of R's native GLM function. So let's say you now wanted to build another model, but now it's a logistic regression model where you want to predict whether or not someone has a professional degree for some reason. And this is a binary variable, right? And you want to use wage as your explanatory variable. And let's say, because it's a logistic regression, just like you do in R's GLM command, you specify that it's a binomial family, the data distribution, and then of course it's the same data pointer, still pointing to the D1 object. That's where it goes. So, oh, whoops, sorry, I spelled that wrong. So binomial, yes, that's what it's spelling. Probably give a different error message, but there's a family called binomial, but this is what it's doing right now in the back end is it's running a logistic regression on, again, that 20 million row data table. And you can get the summary of M1 this way. And yeah, that's what's happening. You get the intercept term, the weight, and all the nice summary statistics that you get from a logistic regression. And that was, again, very, very fast. Imagine if you had to run a 20 million row logistic regression in R. I mean, that would take a long time. Okay, so that's logistic regression. Now, as we've seen many times, and as sort of a practitioner of data science, I've often had to bring in columns and data that lives in different tables or different data sources. Right? So let's suppose that you want to bring in additional variables that live in a different database table. What this means in SQL speak is you got to do a table join at some point. But you can actually do database joins directly from R using familiar R syntax. So like I mentioned at the beginning of this talk, there's a function called merge in R, which basically is the R equivalent of SQL joins. And it does merges on data frames and matrices. You can actually, there's a merge function in PivotalR that mimics the syntax and functionality of the merge command in native R. Okay, so let's just take a look at, again, what database objects exist in this database that we've connected to. And, let's say there's another table, conveniently named census 1 part 2 that you want to bring in data from. Right? So let's do that. And you do that with the merge function. Okay, so let's create a new DB data frame object that points to census 1 part 2. It's establishing a connection from that database table to this R object called D2. Okay. And you can do the same thing that we've done with D1. You can see the names of D2, and you can see here that there's also row ID, which is great, which gives us a joining key. But there's also additional variables like whether or not a person rents a house and whether or not a person is married. Let's say we want to use this information to build a better model. Okay, so what we're going to do is then pretty much create a new R object that joins D1 and D2 together. Okay, so let's take a look and just review again what objects are available in D1. So these are the ones from here, and the common key is this row ID, which I know in advance which I know that the row ID column could be used as a joining key. Okay, so let's do that. Let's create a new R object called D, which merges D1, D2, and this by statement tells you how to join these two data objects. In this case, I want to join by row ID. And this is actually identical to the syntax of R's native merge function. All right, so that's done. And now let's get the names of D. What we want to expect now is getting a superset of the names of the columns in D1 and the columns in D2. And this is exactly what we get back, right? So we get a fuller table now, and this is actually kind of nice because if you notice here, there are columns called serial number and H state in both of these two tables, in both of the source tables. This merge function is able to intelligently rename these columns so that there's no duplication there. Okay. And then another thing to notice is after you issue a merge command under PivotalR, the class of D becomes the db.rQuery. And if you want, like we've seen before, you can easily translate between a db.rQuery object and a db.table object by using the db.dataframe function. So now let's reassign D as a DB, a real DB table, D, and let's call this new table inside of the database census 1 merged, because that we merge these two source tables together. So now what it's doing is it's now creating a new table inside of the database called census1_merged, which is basically a join between D1 and D2, and which contains all the columns specified here. Okay. So now let's take a look at the class of D. Now it's a db.table object, it's a pure pointer, and also let's take a look at the names of D. That's great. You can also do a preview of D, the first 10 rows. Okay, so that's that. And yeah, so this is really just an example of showing you that really you don't need to know any SQL to do a join, a SQL join. If you are a PowerR user and if you're familiar with this merge command, that's really all you need to know to be able to join tables that live inside of a SQL database like Greenplum. Okay, so this is really powerful stuff. Okay, so now that we have this merge table, let's also now run a new model that leverages some of this new data. So let's reassign our one as a new MADlib.lm object. We're still using wage as a response variable. Let's say we want to run a model with professional, rooms, and house, and married as a response variables, and the data that we're using lives in the object called D. So we're again issuing the command, and again, just to re-emphasize, none of the model estimation is actually happening in R. It's all happening inside of the database via MADlib. It's already executed, and you can get model summaries this way. All right, so we've gone through a lot of stuff, but we're not quite done yet. We just want to highlight, one more piece of functionality that's available in PivotalR, which is the support for the as factor style of functions that are available in R. Right? So suppose we had reason to believe that there are considerable differences in wage between states that were maybe not explained by the explanatory variables. Right? So actually, before talking about the as factor functionality, one thing that is also really great about PivotalR is that it has support for the sort of the by function family of functions in R. And by is actually a wrapper, the tapply function in R. So you can actually do that with basically issue a by function command on tables that live inside of Greenplum and have those computations happen inside of the database. So I'll show you what I mean by that. Right? So, maybe as we're gathering evidence for this claim, we want to compute the mean wage by state. So we can do that as follows. So first of all, let's create a query object called mean wage by state. Issue that by command where we want to focus on the wage column, and we want to compute the mean of the wage column, but we want to do this by each state. This is actually identical to the syntax of by in native R. This is pretty powerful. And I think I got that right. Let's kick that off. So that issued in our query object, and let's now preview the mean wages by state. There we go. So we have mean wages for each state and U.S. territory here, and you can see that there are considerable differences in the wages that are there. And this is a theory. It hasn't obviously been proven or anything, but let's just suppose now that we have some reason to believe that there are differences between wage and states, and that you'd want to now put in a different intercept term for each state in your regression model. Okay. And before we do that, this is essentially just support for group by like statements in SQL. So again, the end user doesn't have to know anything about group bys. They just have to know how to use the by function in R to be able to do this. Okay. Okay, so let's just review what we have here in terms of names. Let's take a look at that H state column. Okay, so let's do a preview of the, just fetch me 10 rows from that table. And H state, it's basically an integer is coded for each state or U.S. territory, and it's not in. I know this data, so it's actually not directly like 150 as far as I remember, but basically there are 52 distinct integers, and each of these distinct integers maps to a certain state or territory in the U.S. And what you will see here is that if you wanted to create a separate sort of intercept term for each state, this is going to require dummy coding. But R actually provides a nice interface to this through its factor class of data types. So in any situation like this, if you wrap, let's say, H state underscore X with as factor, then R sort of automatically in the back end knows to dummy code H state and then give you results sort of in a nice, concise way. You don't have to actually manually do the dummy coding yourself. Well, the good news is that PivotalR also has this functionality, and it's able to do dummy coding on big data sets, sort of all in the back end, under the hood, and provide a nice user interface for that. So here's sort of what I mean by that. Okay, so let's now create a new model called M1 underscore state. On a regression model, where wage is still the response variable, but let's now tell R gives me a separate intercept for each state, just like you would in the native lm function in R. Let's keep the variables that we had. That we had originally, and then the data is still C. What this is going to do is it's actually going to automatically dummy code H state underscore X, and then estimate a separate intercept for each state. This is now a really big regression model. It's going to be a regression with over 50 explanatory variables that's going to run in the back end. 20 million records. Yeah, so it's computing again. None of the computations are happening inside of R on my laptop, but this is actually all going on inside of the Github database. Yeah, like I said, it's a regression with 20 million rows and over 50 columns. So it's a pretty big regression. So yeah, because there's more columns now, notice that it'll take slightly longer than the regression model that we've run earlier. But it should close pretty soon. Okay. Oh, right. So that was my mistake here. Actually, there is no column called room. It's actually called room with an S. Actually, just put that in there. Let's rerun that. So it's still, executing on that. again, even with the as factor, you could have also just used the tilde dot functionality in R if you want to have shortcuts in terms of how many variables that you want to enter into the model explicitly into the MADlib.lm function. Looks like it's just about to finish running. All right, so again, a regression model, 20 million rows, over 50 explanatory variables has already finished. And here we go. This is the regression summary table. So we have now a coefficient for each state, and the baseline state is the state that's coded as 1. And you have now coefficient estimates for each of the intercept terms and the original set of explanatory variables. So this sort of concludes the demo of PivotalR in its initial release. I just wanted to thank you again for listening in, and also want to stress that we've gone through a lot of material here and a lot of functionality, but this is actually only a selection of all the stuff that's in PivotalR, even with the current release. So I definitely ask you to check out the documentation and kind of explore the other functions that are available to you in this R library. We'll probably do another one of these recording sessions once we have another major release out of PivotalR, which will be very soon. Thank you and take care.